On the afternoon of May 25, 1979, the American sky was effectively locked down. Following the catastrophic crash of American Airlines Flight 191, just moments after takeoff from Chicago O'Hare, a tragedy that claimed 273 lives, the Federal Aviation Administration made an unprecedented decision. They issued a sweeping grounding order for an entire fleet. The aircraft in question was not an experimental prototype, but one of the most prominent and widely used airliners in the world, the McDonnell Douglas DC-10. Just a decade earlier, this massive three-engine widebody was hailed as the crown jewel of a new aviation era. It was designed to democratize the skies, carrying hundreds of passengers across continents with unprecedented efficiency. It represented the towering ambition of the McDonnell Douglas Corporation, an absolute titan of American aerospace. Yet the dream rapidly deteriorated. Instead of being remembered as the pinnacle of commercial flight, it inherited a dark, unforgiving nickname from a terrified public and a relentless press: the Death-C-10. How did a magnificent machine, engineered by some of the most brilliant minds in the industry, become synonymous with systemic failure? Was the aircraft inherently doomed by a fatal design flaw? Or was it the tragic victim of immense corporate pressure, fierce commercial rivalries, and a regulatory framework that compromised on safety to protect the bottom line? This is the complete story of the McDonnell Douglas DC-10. It is a profound look at how the pursuit of the skies collided with the unforgiving realities of the boardroom, forever altering the landscape of commercial aviation. Let's uncover the truth behind the rise and fall of a compromised giant. In the late 1960s, the American aviation landscape was undergoing a violent, expensive transformation. Passenger traffic was doubling every 5 years. The skies were filling, the airport terminals were bottlenecking, and the solution, according to the industry, was sheer size. In Seattle, Boeing had just bet its entire corporate existence on the 747, a gargantuan four-engine marvel that fundamentally rewrote the mathematics of long-haul flight. But the 747 was not the answer to every problem. For domestic carriers operating within the United States, Boeing's Queen of the Skies was simply too large, too expensive, and too heavy for the vital, high-frequency transcontinental routes. American Airlines, under the technical direction of their legendary executive Frank Kolk, looked at the 747 and saw excess. What American Airlines needed was the entirely different kind of machine. They wanted a wide-body aircraft capable of carrying 250 passengers from coast to coast, but it had to be nimble enough to operate out of smaller, noise-restricted airports like New York's LaGuardia. It needed the economics of a twin-aisle cabin without the punishing fuel bills and maintenance costs of 4 engines. Because engine technology of the era could not yet produce a power plant reliable and thrust-heavy enough for a massive twin-engine jet, the physics dictated a compromise: 3 engines. The era of the trijet was born. For the American aerospace industry, the American Airlines requirement was not just a lucrative contract, it was a kingmaker. Whichever manufacturer won this specification would capture a near monopoly on the domestic widebody market for a generation. 2 titans of American manufacturing answered the call, setting the stage for one of the most brutal, high-stakes corporate wars in aviation history. In one corner stood Lockheed, a legendary defense contractor desperate to re-enter the commercial airliner business after the troubled legacy of its L-188 Electra a decade prior. Lockheed's answer was the L-1011 TriStar. It was an absolute technological masterpiece. The TriStar featured highly advanced avionics, an innovative S-duct design for its tail engine that improved aerodynamics, and a visionary autopilot system capable of landing the aircraft blind in zero visibility. Lockheed was not just building an airplane, they were building the future. In the other corner stood McDonnell Douglas, formed in 1967 from the merger of the financially struggling commercial giant Douglas Aircraft and the flush, military-focused McDonnell Aircraft. The new conglomerate possessed immense resources, but carried a deep cultural divide. Douglas engineers knew how to build airliners that operators loved, like the legendary DC-8 and DC-9. But the McDonnell executives, hailing from the defense sector, managed strictly by the spreadsheet. They demanded strict cost controls, rigid schedules, and immediate profitability. Their answer to the tri-jet requirement was the DC-10. Compared to the L-1011, the DC-10 was a highly conservative machine. Instead of a complex, aerodynamic S-duct, McDonnell Douglas simply mounted the third engine straight through the vertical stabilizer, a heavier, less elegant solution, but one that was vastly easier and faster to engineer. While Lockheed partnered exclusively with Rolls-Royce to develop the revolutionary RB2111 engine, McDonnell Douglas offered airlines a choice between reliable existing power plants from General Electric and Pratt & Whitney. The TriStar was brilliant. The DC-10 was pragmatic. But in the boardrooms of American aviation, pragmatism often wins. The pressure between the two firms was suffocating. Both companies knew the market could only sustain one domestic trijet. The first to fly, the first to certify, and the first to deliver would survive. The loser would face financial ruin. The race officially ignited on February 19, 1968, when American Airlines placed a massive launch order for 25 McDonnell Douglas DC-10s. It was a devastating blow to Lockheed, but the war was far from over. Within weeks, Lockheed struck back, securing massive orders from TWA and Eastern Airlines for the TriStar. The competition devolved into a bitter, day-by-day trench war for market share. Sales teams offered massive discounts, guaranteed financing, and aggressive delivery timelines that engineering departments could barely fathom. At the McDonnell Douglas plant in Long Beach, California, the executive mandate was absolute. The DC-10 must beat the TriStar to market. The factory floor became a crucible of constant motion. Thousands of workers, millions of rivets, and miles of wiring were assembled under the relentless ticking of a corporate stopwatch. Developing a clean-sheet wide-body aircraft requires hundreds of millions of dollars in upfront capital. It is an all-or-nothing gamble. If the DC-10 arrived late, the airlines would simply buy the TriStar, and McDonnell Douglas would face a financial catastrophe from which its commercial division might never recover. Every day the DC-10 lingered in development was a day Lockheed could steal a customer. The schedule became the supreme authority. Engineers who raised concerns about complex systems were pressured to find the fastest, certifiable solution, not necessarily the most robust one. The corporate culture shifted from the meticulous, safety-first legacy of the early Douglas days to an aggressive, timeline-driven industrial machine. In their desperation to accelerate production and maximize the aircraft's cargo volume, a crucial selling point to airlines looking for secondary revenue, McDonnell Douglas engineers began making subtle, fateful decisions. They needed to squeeze every available cubic inch out of the lower fuselage. They needed systems that could be built quickly and assembled cheaply. The DC-10 was not designed to be flawed. It was designed to be fast, competitive, and profitable. But in the ruthless calculus of the wide-body war, the pressure to beat Lockheed had introduced a deadly variable into the blueprints at Long Beach. The race to the sky had been won, but the compromises made on the drafting tables were already waiting in the dark. To understand the tragedy of the DC-10, one must first understand the brutal economics of the airline industry. While passengers occupy the upper deck, they merely cover the operating costs of a flight. The true profit margin for an airline lies beneath their feet, in the belly of the aircraft. Cargo is the invisible lifeblood of commercial aviation. When McDonnell Douglas engineers designed the DC-10, they were given a strict mandate from their airline customers: maximize the lower cargo volume. Every cubic foot of space dedicated to freight equated to hundreds of thousands of dollars in revenue over the lifespan of the airframe. This financial imperative immediately created a severe engineering dilemma regarding the cargo doors. In aviation, the safest and most traditional way to secure a pressurized cabin is to use what is known as a plug door. A plug door is physically larger than the opening it seals. To close it, the door is pulled inward. As the aircraft climbs and the cabin pressurizes, the higher air pressure inside the fuselage physically forces the door outward against its frame, wedging it tighter and tighter. The higher the airplane flies, the safer a plug door becomes. It is a foolproof system governed by the immutable laws of physics. However, a plug door requires internal clearance to swing open and shut. In the lower deck of a wide-body jet, that internal swing space would consume valuable room that could otherwise be used to store luggage and freight pallets. To save this precious space, McDonnell Douglas made a fateful decision. They abandoned the traditional inward opening plug door in favor of an outward opening door. An outward opening door on a pressurized aircraft is inherently dangerous. At a cruising altitude of 35,000 feet, the pressure differential between the breathable air inside the cabin and the thin, freezing atmosphere outside exerts thousands of pounds of force on every square inch of the fuselage. An outward opening door is actively trying to blow wide open. It is entirely dependent on its mechanical latches to hold it shut against the immense power of the cabin pressure. If those latches fail, the door will violently eject from the aircraft. To secure this massive outward opening door, Douglas engineers designed a complex mechanism. It relied on a series of heavy metal hooks driven by electric actuators. Once the hooks rotated over the latch spools, a baggage handler on the tarmac would pull down an external locking handle. This action was supposed to drive metal locking pins behind the latches, physically preventing them from rotating backward and opening in flight. But the system was fundamentally flawed. The electric actuators were incredibly powerful. So powerful that if the locking pins did not align perfectly, the sheer mechanical force of the system could bend the metal linkages. A baggage handler could pull the handle down, forcing the exterior lever to sit flush against the fuselage, and the cockpit indicator light would turn off, signaling a secure door. Yet the locking pins might not actually be in place. The door could be resting entirely on the edge of the latches, a hair trigger waiting to be pulled by the building pressure of altitude. McDonnell Douglas did not manufacture the fuselage of the DC-10 themselves. They subcontracted the work to Convair, a division of General Dynamics based in San Diego. The engineers at Convair, looking at the blueprints, immediately recognized the danger, but the true horror of the design was revealed during a ground test on May 29, 1970. Inside a Convair testing facility, a prototype DC-10 fuselage was being pressurized to simulate the stresses of high-altitude flight. Suddenly, the aft cargo door violently blew off its hinges. The sudden explosive decompression in the lower hold created a massive vacuum. The air pressure in the passenger cabin above had nowhere to go, and the floor of the cabin catastrophically collapsed downward into the cargo hold. In most aircraft, a floor collapse is expensive damage. In the DC-10, it was a death sentence. To save weight and streamline manufacturing, Douglas engineers had routed all the primary hydraulic lines and control cables, the vital nervous system that allows the pilots to steer the aircraft, directly through the floor beams. When the floor collapsed during the ground test, those control lines were severed. Had this happened in the air, the pilots would have instantly lost all ability to fly the plane. This test failure should have halted the entire DC-10 program. The responsible engineering decision was to completely redesign the door to a plug type, or at the very least, reroute the critical flight control cables into the ceiling. But it was 1970. The wide-body war against Lockheed was reaching its absolute climax. Redesigning the cargo door in the hydraulic routing would delay the DC-10 by months, costing McDonnell Douglas tens of millions of dollars and potentially losing the market to the TriStar. Management refused to stop the assembly line. Instead of fixing the root cause, Douglas applied a series of minor mechanical band-aids. They added small vent holes between the cabin and the cargo hold, hoping to equalize pressure if the door blew, and slightly modified the wiring of the locking system. The fundamental vulnerabilities, the electric latching mechanism and the control cables resting in the floor, remained untouched. Despite the internal warnings, the Federal Aviation Administration, FAA, approved the design. At the time, the FAA was deeply intertwined with the manufacturers it was supposed to regulate, often deferring to the technical expertise of the companies themselves. The DC-10 was granted its type certificate. In August 1971, the McDonnell Douglas DC-10 officially entered commercial service. It was a triumph of marketing and industrial scale. Passengers marveled at its spacious twin aisles, its quiet cabin, and its smooth ride. Airlines celebrated its fuel efficiency and massive cargo capacity. But beneath the plush carpets of the passenger deck, hidden from the flight crew and the public, the fatal compromise had been built into the metal. The DC-10 was a magnificent machine, but every time it climbed into the sky, it was relying on a flawed lock to hold back a disaster. Theory and ground tests are sterile environments, governed by controlled variables and anticipated outcomes. Reality, however, is unforgiving. On June 12, 1972, less than a year after the McDonnell Douglas DC-10 entered commercial service, the theoretical warnings of the Convair engineers materialized in the sky over Ontario, Canada. American Airlines Flight 96 was a regularly scheduled transcontinental route originating in Los Angeles, bound for New York's LaGuardia Airport, with a brief stopover in Detroit. The aircraft was a nearly brand new DC-10. As the massive trajet lifted off from Detroit Metropolitan Wayne County Airport, climbing through 11,750 feet over the town of Windsor, the cabin was quiet. Flight attendants were preparing for the beverage service. Passengers were settling in for the short remaining leg of the journey. Then a concussive blast ripped through the rear of the aircraft. It was not a bomb, though to the terrified passengers, it sounded like one. The aft cargo door, secured by the flawed, electrically actuated latching system, had violently blown off the side of the fuselage. Just as it had during the catastrophic 1970 ground test, the sudden departure of the massive door created an instantaneous, explosive decompression in the lower cargo hold. The pressurized air in the passenger cabin above immediately sought the path of least resistance, rushing downward with the force of a hurricane. The structural integrity of the cabin floor failed instantly. The floor beams buckled and collapsed downward into the yawning void of the cargo bay. As the floor caved in, it dragged down the passenger seats, a portion of the aft galley, and most critically, the vital flight control cables routed directly through the floor structure. In the cockpit, the flight crew was suddenly confronted with a cascade of terrifying anomalies. A blizzard of dust and debris blew through the flight deck. The rudder pedals jammed. The control yokes lost nearly all of their pitch and roll authority. The number 2 engine, mounted in the tail, suddenly lost power as its throttle cable was severed by the collapsing floor. In a matter of seconds, Captain Bryce McCormick and his crew found themselves commanding a massive, crippled wide-body jet that was rapidly losing its ability to fly. Under normal circumstances, an aircraft with severed hydraulic lines and jammed flight controls is a doomed machine. But Captain Bryce McCormick was not an average pilot. Months before this flight, deeply curious about the aerodynamics of this new generation of wide-body jets, McCormick had spent hours in an American Airlines flight simulator. He had intentionally practiced a seemingly impossible scenario, flying the DC-10 using nothing but the thrust of its engines, anticipating a day when hydraulic controls might fail. Now that nightmare scenario was a reality. With the tail engine dead, the rudder jammed to the right, and the elevators barely responding, McCormick took manual control of the throttles for the 2 wing-mounted engines. By carefully increasing thrust on the left engine and decreasing it on the right, he was able to steer the massive aircraft. By collectively raising or lowering the thrust of both engines, he could control the pitch, bringing the nose up or down. It was an agonizing, delicate ballet of aerodynamics and raw engine power. McCormick declared an emergency and managed to slowly, laboriously turn the crippled DC-10 back toward Detroit. The approach was terrifying. The aircraft was coming in fast, heavy, and largely unsteerable. The crew had to use emergency procedures to lower the landing gear, locking it into place by gravity. As the runway threshold approached, McCormick used differential thrust to keep the plane aligned. The DC-10 slammed onto the runway, veering dangerously toward the grass before the crew managed to apply reverse thrust and heavy braking, bringing the 330,000-pound machine to a smoking halt. All 336 passengers and crew members survived. Several were injured, and a flight attendant had narrowly avoided being sucked out of the gaping hole in the fuselage, but there were no fatalities. Captain McCormick's extraordinary airmanship had saved hundreds of lives. The DC-10 had survived its first major structural failure in flight. But the true tragedy of the DC-10 story is not what happened over Windsor. It is what happened next in the boardrooms of Washington and Long Beach. The Windsor incident triggered an immediate and aggressive investigation by the National Transportation Safety Board, NTSB. When federal investigators examined the crippled American Airlines jet on the tarmac in Detroit, they did not have to search long for the cause. The aft cargo door was missing, and the floor had collapsed. It was a perfect, terrifying replication of the 1970 Convair ground test. The NTSB investigators discovered that the baggage handler in Detroit had followed the exact procedures to close the cargo door. He had pressed the button to actuate the electric latches and pulled down the locking handle. However, the pins had not properly aligned behind the latches. Just as the engineers had feared, the immense torque of the electric actuators simply bent the metal linkages. The handle stowed perfectly flush against the fuselage, and the cockpit warning light extinguished, falsely signaling to the pilots that the door was secure. In reality, the door was a loaded spring, waiting for the altitude pressure to push it open. Chuck Miller, the director of the NTSB's Bureau of Aviation Safety, recognized the extreme gravity of the situation. This was not a maintenance error. This was a fundamental, catastrophic design flaw in a commercial airliner carrying hundreds of passengers every day. The NTSB immediately drafted two urgent safety recommendations. First, McDonnell Douglas had to fundamentally redesign the cargo door locking mechanism to ensure it could not be closed unless the locking pins were physically engaged. Second, they recommended that the flight control cables be rerouted into the ceiling or structurally reinforced so that a floor collapse would not render the aircraft unflyable. To enforce these recommendations, the NTSB formally requested that the Federal Aviation Administration, FAA, issue an Airworthiness Directive, AD. In the aviation industry, an Airworthiness Directive is the ultimate regulatory weapon. It is a legally binding mandate. If an AD is issued, the affected aircraft cannot legally carry paying passengers until the required modifications are completed. Furthermore, an AD is a highly public document. It acts as a glaring neon sign to the world, the press, and the airlines that a specific aircraft has a dangerous flaw. For McDonnell Douglas, an airworthiness directive on the DC-10 in the summer of 1972 would have been a commercial disaster. The widebody war was still raging. Lockheed was aggressively marketing the TriStar, highlighting its safety and advanced engineering. If the DC-10 fleet were grounded by a mandatory AD, airlines might cancel their orders. The financial stability of the entire Douglas commercial division was at risk. Under immense corporate pressure, Jackson McGowan, the president of the Douglas Aircraft Division, picked up the phone. He called John Schaffer, the administrator of the FAA. McGowan argued that an airworthiness directive was unnecessarily punitive. He promised that McDonnell Douglas had already developed a fix, a small support plate, and a viewing window installed on the door so baggage handlers could visually confirm the pins were in place. He assured the FAA that Douglas would issue service bulletins to the airlines, instructing them to make these modifications immediately. Schaffer, representing an agency that historically viewed manufacturers as partners rather than subjects of strict oversight, agreed. The FAA bypassed its own regulatory protocols. Instead of issuing the mandatory, legally binding airworthiness directive, Schaffer and McGowan entered into what became infamously known as a gentleman's agreement. The FAA would stay quiet. McDonnell Douglas would handle the problem internally through voluntary service bulletins. The planes would keep flying. The production line in Long Beach would not be interrupted. This decision was a profound betrayal of public safety. A service bulletin is fundamentally different from an airworthiness directive. While airlines generally follow service bulletins, they are often treated as routine maintenance tasks, slotted into schedules when convenient. They lack the legal urgency and the rigid inspection requirements of an AD. By choosing a gentleman's agreement over regulatory enforcement, the FAA effectively outsourced the safety oversight of a fatally flawed aircraft back to the manufacturer that had compromised the design in the first place. The fix itself was terrifyingly inadequate. Adding a small viewing window and a support plate did not change the fact that the door still opened outward, nor did it change the fact that the control cables were still vulnerable in the floor. But the paperwork was filed. The crisis was quietly managed. The American Airlines DC-10 was repaired and returned to service. The executives at McDonnell Douglas exhaled, believing they had narrowly avoided a public relations catastrophe. The widebody war continued, unimpeded by regulatory intervention. They had successfully ignored the warning, but the laws of physics do not negotiate, and they are not bound by gentlemen's agreements. In factories and hangars around the world, there were still DC-10s operating with the original, unmodified cargo doors. It was no longer a question of if the door would blow again. It was only a question of when, and whether there would be a pilot as skilled as Bryce McCormick in the cockpit when it did. For nearly 2 years following the Windsor incident, the McDonnell Douglas DC-10 flew under a shadow of a quiet, lethal gamble. The gentleman's agreement between the FAA and the manufacturer had kept the planes in the air, relying on voluntary service bulletins to patch a fundamental structural vulnerability. But in the complex global web of commercial aviation, voluntary fixes and factory-level band-aids are prone to the simplest of human errors. On March 3, 1974, that gamble collapsed with terrifying finality. The setting was Orly Airport in Paris. Turkish Airlines Flight 981, a nearly new McDonnell Douglas DC-10 registered as TC JAV, was preparing for the final leg of its journey from Istanbul to London. Normally, this leg of the flight was lightly booked. However, on this particular Sunday, a massive strike by the ground staff of British European Airways had stranded thousands of travelers in Paris. Desperate to get home, a massive influx of passengers, including a British rugby team, bankers, students, and fashion models, were transferred to the Turkish Airlines Flight. The aircraft was suddenly packed with 346 passengers and crew. Down on the tarmac, the loading process was hurried. An Algerian baggage handler named Mohammed Mahmoudi was tasked with securing the aft cargo door. He was an experienced worker, but he did not speak English or Turkish. He was unaware of the complex, fragile nature of the DC-10's door-locking mechanism. He pushed the button to close the heavy outward opening door and pulled down the metal locking handle. The handle was stiff, requiring significant force, but Mahmoudi pushed it flush against the fuselage. Inside the belly of the plane, just as the engineers at Convair had feared and exactly as had happened in Detroit, the sheer torque of the electric actuators bent the metal linkages. The locking pins did not slide into place behind the latches. Following the Windsor incident, McDonnell Douglas had supposedly installed a small viewing window on the cargo doors of all its aircraft, so ground crews could visually verify that the locking pins were engaged. However, the instructional placard next to the window on TC JAV was written only in English and Turkish. Mahmoudi, reading neither language, simply checked that the handle was flush, just as he did on dozens of other aircraft. Up in the cockpit, the warning light went out. Captain Nejat Berkoz and First Officer Oral Yücel were led to believe their aircraft was perfectly secure. Flight 981 lifted off from Orly Airport into a clear, crisp afternoon sky, turning north toward London. The massive widebody climbed steadily, passing over the town of Meaux. As the aircraft reached an altitude of 11,500 feet, the pressure differential between the pressurized, comfortable passenger cabin and the freezing, thin atmosphere outside reached a critical threshold. The bent linkages holding the cargo door could no longer withstand the immense outward force. At 12:40 p.m., the aft cargo door violently blew off the fuselage. The result was an explosive decompression of catastrophic proportions. The air inside the cabin, suddenly seeking the massive hole in the lower deck, rushed downward with the force of a bomb. The structural floor beams, never designed to withstand such a violent pressure differential, instantly buckled and collapsed. Because Flight 981 was fully loaded, the consequences were immediate and horrific. As the floor caved in, 2 entire rows of passenger seats, carrying 6 people, were ripped loose and sucked entirely out of the aircraft, falling into the French countryside below. But the fatal blow to the aircraft was mechanical. When the floor collapsed, it took the vital flight control cables with it. Unlike Captain Bryce McCormick over Windsor, who had maintained marginal control because only some cables were jammed, the floor collapse on Flight 981 was absolute. The primary elevator cables, the rudder cables, and the engine throttle lines were completely severed or hopelessly pinned. In the cockpit, Captain Berkoz and First Officer Yücel were instantly stripped of their ability to fly the airplane. The cockpit voice recorder captured the sudden roar of the decompression, followed by the terrifying realization that the control yokes were dead. The aircraft's nose pitched down violently, and it began banking sharply to the left. The pilots desperately tried to use the engine throttles to pull the nose up, just as McCormick had done. But the severed lines meant the tail engine was unresponsive. The massive DC-10, weighing hundreds of thousands of pounds, was now in a steep, unrecoverable dive. For 77 agonizing seconds, Flight 981 plummeted toward the Earth. The aircraft accelerated to nearly 500 miles per hour, its aerodynamic structure screaming under the stress. It crashed into the Ermenonville forest, a dense woodland northeast of Paris. The kinetic energy of the impact was so absolute that the massive widebody simply disintegrated, shredding thousands of trees and reducing the machine and everyone aboard to unrecognizable fragments. All 346 people on board were killed instantly. At the time, it was the deadliest aviation disaster in human history. The aftermath of the Ermenonville crash was a scene of apocalyptic devastation. French investigators, aided by experts from the NTSB and the FAA, arrived at a crash site that stretched for miles through the torn forest. But the most crucial piece of evidence was not found among the shattered remains of the fuselage. 9 miles behind the main impact crater, in a turnip field near the town of St. Petrus, a farmer discovered the intact aft cargo door of the DC-10. Nearby lay the 6 passenger seats that had been ejected from the aircraft. For the NTSB investigators, the discovery of the door miles away from the crash site induced a sickening sense of déjà vu. The latches, the bent linkages, the position of the handle, it was a flawless, terrifying replica of the American Airlines Windsor incident from 2 years prior. The worst fears of the safety board had materialized. The warning they had tried to elevate to a mandatory directive had been ignored, and 346 people had paid the price. But as investigators dug deeper into the history of the Turkish Airlines jet, the narrative shifted from a tragic engineering failure to a staggering corporate scandal. Following the gentleman's agreement in 1972, McDonnell Douglas had promised to issue service bulletins to fix the doors of all existing and future DC-10s. One of the key fixes was the installation of a metal support plate designed to prevent the linkages from bending. When investigators examined the manufacturing records for TC-JAV, the paperwork originating from the McDonnell Douglas plant in Long Beach clearly indicated that the support plate had been installed. The documents bore the stamps of 3 separate factory inspectors certifying that the crucial safety modification was complete. Yet when investigators looked at the actual cargo door recovered from the French turnip field, the truth was undeniable. The support plate was not there. Whether it was gross negligence on the assembly line, a deliberate falsification of records to keep the production schedule moving, or a catastrophic failure of quality control, the aircraft had been delivered to Turkish Airlines with a known, fatal flaw, despite paperwork claiming it was safe. Furthermore, the viewing window that had been installed was utterly useless without multilingual instructions and rigorous ground crew training, which McDonnell Douglas had failed to ensure. The revelation sent shockwaves across the globe. The secret gentleman's agreement between the FAA and McDonnell Douglas was dragged into the harsh light of public scrutiny. The United States Congress convened emergency hearings. The press launched a relentless assault on the manufacturer and the regulatory agency. The narrative was inescapable. The FAA had abdicated its duty to protect the public, bowing to the financial pressures of a massive defense and aerospace contractor. The Ermenonville tragedy proved that relying on the goodwill and internal quality control of a corporation engaged in a fierce market war was a recipe for disaster. In the immediate aftermath, the FAA was finally forced to issue the airworthiness directive they should have issued in 1972. All DC-10s were legally mandated to have their cargo doors fundamentally redesigned so they could not physically be closed without the pins engaging. The mechanical flaw was finally permanently fixed, but the damage to the DC-10's reputation and to the legacy of McDonnell Douglas was irreversible. The aircraft was no longer viewed as a marvel of modern engineering. In the eyes of the flying public, it was a compromised machine. The wide-body war had pushed a manufacturer to cut corners, pushed a regulator to look the other way, and transformed a technological marvel into a flying coffin. The fix had been made, but for the DC-10, the long, painful decline in the American market was only just beginning. The mechanical flaw that brought down Turkish Airlines Flight 981 had finally been rectified. Following the mandate of the Delayed Airworthiness Directive, McDonnell Douglas initiated a massive global retrofit of the DC-10 fleet. The cargo doors were fundamentally redesigned, adding a closed-loop mechanical locking system that made it physically impossible for the handle to be stowed unless the locking pins were perfectly engaged. By late 1974, the outward opening doors were no longer a hair trigger waiting to spring. From a purely engineering standpoint, the DC-10 was finally safe. But in the brutal arena of commercial aviation, an aircraft manufacturer sells two distinct products: performance and trust. McDonnell Douglas had delivered the former, but they had comprehensively shattered the latter. The autopsy of the DC-10's development was just beginning, and what investigators found buried in the corporate archives would transform a tragic engineering oversight into a historic corporate scandal. The smoking gun emerged during the massive, multi-district litigation that followed the Paris crash. It came in the form of a devastating internal document authored by Dan Applegate, the director of product engineering at Convair, the subcontractor responsible for building the DC-10 fuselage. Applegate had written the memo on June 27, 1972, mere weeks after the American Airlines Windsor incident and nearly 2 full years before the Ermenonville tragedy. In his memo, Applegate laid out the exact sequence of events that would eventually bring down Flight 981. He explicitly warned his superiors that the fundamental safety of the cargo door latching system had been progressively degraded by design compromises. He stated with chilling clarity that it was only a matter of time before a cargo door blew off at high altitude, which would inevitably cause the floor to collapse, severing the flight control cables and resulting in the total loss of the aircraft. Applegate urged Convair management to confront McDonnell Douglas and demand a total redesign of the door and the routing of the control cables. But his superiors refused. In their written response, Convair executives expressed fear that if they forced the issue, McDonnell Douglas might penalize them financially, forcing Convair to absorb the immense costs of the redesign. The wide-body war was too expensive, the margins were too thin, and the corporate relationship was too fragile. The memo was quietly filed away in a drawer in San Diego, buried under the weight of financial self-preservation. When the Applegate memo was leaked to the press in 1974, the American public exploded in outrage. It was undeniable proof that the builders of the DC-10 knew the aircraft was fatally compromised and had consciously chosen to keep it flying. The scandal reached the highest levels of the United States government. The United States Congress convened scathing investigative hearings. Lawmakers dragged FAA Administrator John Schaffer and executives from McDonnell Douglas into the chambers, demanding to know how a gentleman's agreement had been allowed to supersede federal aviation law. The hearings exposed a deeply entrenched culture of regulatory capture, revealing an FAA that acted more like an industry partner than a public watchdog. The agency was forced to undergo a massive internal restructuring, fundamentally altering how it certified aircraft and issued safety directives. But the most immediate and profound damage was inflicted on the open market. For the first time in the modern jet age, the American flying public became actively terrified of a specific airplane. Travel agents reported a massive surge of passengers explicitly demanding to be booked on Boeing 747s or Lockheed L-1011s, refusing to set foot on a DC-10. Corporate travel departments issued policies forbidding their employees from flying on the McDonnell Douglas trijet. The press was relentless, publishing diagrams of the cargo doors and investigative pieces detailing the corporate compromises. It was during this period that the aircraft acquired its grim, inescapable nickname, the Death-C-10. For the airlines that had invested billions of dollars into their DC-10 fleets, the stigma was a financial nightmare. A wide-body jet is a massive capital asset. It cannot make money if passengers refuse to board it. Desperate to protect their revenue streams, several airlines resorted to a remarkable public relations strategy. They attempted to erase the aircraft's identity. Ground crews were dispatched with paint and solvent to quietly scrub the DC-10 designation from the forward fuselages of their fleets. Instead of proudly advertising the specific make and model, as had been the tradition since the dawn of the jet age, airlines began referring to the aircraft in their timetables and gate announcements using generic, sanitized terms. It was simply called a luxury airliner, a wide-body jet, or a super trijet. The name McDonnell Douglas had become a liability. It took years of flawless, incident-free operation for the stigma to begin to fade. Slowly between 1975 and 1978, the DC-10 clawed its way back into operational normalcy. The redesigned doors held. The aircraft proved its immense capability, serving as the high-capacity backbone for major carriers like American, United, and Northwest Orient. The trijet was incredibly efficient on transcontinental routes, and pilots generally praised its handling characteristics. By the spring of 1979, the controversy of the cargo doors had largely receded into the annals of aviation history. The DC-10 had survived its baptism by fire and was finally reclaiming its position as a vital, respected pillar of the American commercial fleet. The assembly line in Long Beach was humming, and the ghosts of Paris seemed to have been finally laid to rest. But this recovery was a fragile illusion. The DC-10 was about to encounter a brand new catastrophe. This time, the failure would not originate on the drafting tables of California, but on the concrete tarmacs of the American airline maintenance system. And this time, it would shatter the sky in a way the industry had never seen. By the spring of 1979, the McDonnell Douglas DC-10 had settled into a comfortable, almost mundane rhythm within the American commercial airline system. The horrific memories of the Paris crash 5 years earlier had slowly faded from the public consciousness. The cargo doors had been redesigned, the fleet was performing reliably, and the massive trijet had become a vital, high-capacity workhorse for the nation's largest carriers. It was fulfilling the exact role it had been built for, moving hundreds of Americans from coast to coast with mechanical efficiency. Friday, May 25, 1979, was the beginning of the Memorial Day weekend, traditionally one of the busiest and most chaotic travel periods of the year. At Chicago's O'Hare International Airport, one of the busiest aviation crossroads on the planet, the weather was clear, the winds were calm, and the terminals were packed. At Gate K5, American Airlines Flight 1991 was boarding. The aircraft was a DC-10 loaded with 258 passengers and 13 crew members, bound for Los Angeles. In the cockpit sat Captain Walter Lux, a highly respected veteran who had been flying the DC-10 since its introduction 8 years prior. Beside him were First Officer James Dillard and Flight Engineer Alfred Udovich. It was a perfectly routine afternoon. At 3:02 p.m., Flight 191 was cleared for takeoff on runway 32 right. Captain Lux advanced the throttles, and the massive trijet surged forward, accelerating down the concrete. The heavy aircraft reached its rotation speed, and the nose wheel lifted gracefully off the runway. But at that exact millisecond, just as the main landing gear was leaving the pavement, a catastrophic structural failure occurred. There was a deafening metallic snap. The entire number 1 engine, mounted on the left wing, physically tore itself away from the aircraft. The immense 10,000-pound turbofan and its mounting pylon ripped backward, flipped violently over the top of the left wing, and smashed into the runway, leaving a trail of shattered concrete and sparking metal in its wake. Inside the cockpit, the pilots heard a loud bang and felt a violent shudder, but the architecture of a wide-body jet meant they could not see the wings from their seats. They had no idea that a third of their thrust was simply lying on the runway behind them. The instrument panel lit up with warnings, indicating a loss of power in the left engine. Captain Lux, following decades of training and standard operating procedures for an engine failure on takeoff, held the aircraft steady. The DC-10 was certified to fly, climb, and maneuver safely with only 2 functioning engines. The crew pitched the nose up to maintain a safe climb speed, fully believing they were executing a textbook emergency procedure. But the departing engine had taken more than just thrust. As the pylon ripped away, it tore out a 3-foot section of the wing's leading edge. Crucially, it severed the hydraulic lines that supplied pressure to the left wing's leading edge slats. Slats are aerodynamic devices that extend from the front of the wing to generate extra lift at slow speeds, such as during takeoff. With the hydraulic fluid violently bleeding out of the severed lines, the aerodynamic pressure of the rushing air physically forced the left wing slats to retract back into the wing. The DC-10 was now a fatally asymmetrical machine. The right wing still had its slats extended, generating massive lift. The left wing, with its slats suddenly retracted, lost its lift entirely and went into an aerodynamic stall. Flight 191 reached an altitude of just 300 feet. Suddenly, the aircraft began to roll violently to the left. First Officer Dillard fought the control yoke, desperately trying to level the wings. But without the lift from the left side, the aerodynamics were broken beyond any human intervention. The roll steepened into a vertical bank. The nose dropped. Just 31 seconds after liftoff, American Airlines Flight 191 plunged into an open field and a trailer park just beyond the end of the runway. The massive wide-body, loaded with thousands of gallons of highly flammable jet fuel for the flight to California, erupted into a towering apocalyptic fireball that was visible from the terminal windows. The devastation was absolute. All 258 passengers and 13 crew members were killed instantly, along with 2 people on the ground. To this day, it remains the deadliest single-aircraft aviation accident on United States soil. The nation was paralyzed by the disaster. The sheer scale of the crash, occurring at the country's busiest airport at the start of a holiday weekend, dominated the news cycle. The horror was amplified by a chilling, iconic photograph taken by an amateur photographer from the terminal. The image, broadcast across every newspaper and television network in America, showed the massive DC-10 rolling almost completely upside down just above the ground, its left wing utterly devoid of an engine. Within hours, investigators from the National Transportation Safety Board, NTSB, descended upon O'Hare. As rescue workers combed through the smoldering, unrecognizable debris in the field, federal investigators walked the length of runway 32 right. There, resting quietly on the scarred concrete, was the #1 engine and the torn remnants of its mounting pylon. Initially, the public and the press assumed the engine itself had exploded, but a quick examination proved the General Electric turbofan was completely intact and had been operating perfectly at maximum thrust when it detached. The engine hadn't failed. The structure holding it to the airplane had. The Federal Aviation Administration, still haunted by the accusations of complacency and regulatory capture following the Paris crash of 1974, knew they could not afford a gentleman's agreement this time. The public was terrified. The Death-C-10 moniker roared back into the headlines. FAA Administrator Langhorne Bond ordered an immediate nationwide inspection of the engine pylons on every American-registered DC-10. What the mechanics found in the hangars over the next few days turned a localized tragedy into a systemic nightmare. On several other DC-10s operated by American Airlines and Continental Airlines, mechanics discovered severe stress fractures in the aft bulkhead of the engine pylons. In a few terrifying instances, the cracks were so deep that the engines were dangerously close to falling off during routine maintenance checks. These aircraft had been flying with hundreds of passengers, unknowingly operating as ticking time bombs. The evidence was overwhelming. The pylon mounts were failing across the domestic fleet. On June 6, 1979, less than 2 weeks after the disaster at O'Hare, the FAA took an unprecedented step. Langhorne Bond stepped up to a microphone in Washington and announced the emergency suspension of the McDonnell Douglas DC-10's type certificate. He grounded the entire American fleet. Every single DC-10 in the United States was ordered to stay on the tarmac. Furthermore, foreign airlines were legally barred from flying their DC-10s into American airspace. It was a staggering blow to the aviation economy. Hundreds of flights were canceled. Airlines scrambled to rebook passengers on different aircraft. The assembly line in Long Beach fell under a dark, heavy cloud. A major American manufacturer had its flagship product effectively declared a public menace by the federal government. As the massive Tri-Js sat idle at gates and maintenance ramps across the country, the NTSB focused intensely on the broken pylons. McDonnell Douglas engineers insisted that the pylon was structurally sound, designed to withstand forces far greater than any normal flight could generate. If the design was sound, why were the metal mounts cracking across multiple airlines? The investigators were forced to ask a terrifying question. Was this another fatal compromise originating from the drafting tables of the widebody war? Or was there an invisible force systematically destroying these aircraft in the dark confines of the American maintenance system? The answer to that question would shift the blame, but it would not save the reputation of the DC-10. As the McDonnell Douglas DC-10 fleet sat paralyzed on tarmacs across the United States, the National Transportation Safety Board faced a monumental task. The American public and the global press had already delivered their verdict. The aircraft was a fatally flawed death trap, but engineering investigations do not operate on public sentiment. They operate on metallurgy, flight data, and maintenance logs. When NTSB investigators began examining the cracked engine pylons discovered across the fleets of American Airlines and Continental Airlines, they noticed a baffling inconsistency. The cracks were not universal. Dozens of other DC-10s, operated by airlines like United and Northwest Orient, possessed engine pylons that were in pristine structural condition. If the pylon design was inherently weak, as the public assumed, every heavy-use aircraft should have exhibited stress fractures. The localized nature of the damage pointed away from the drafting tables in Long Beach and directly toward the maintenance hangars of specific airlines. In commercial aviation, the maintenance manual provided by the manufacturer is not a suggestion. It is a rigid legal framework. To perform routine maintenance on the DC-10's wing-mounted engines, the McDonnell Douglas manual dictated a slow, meticulous, two-step process. First, mechanics were required to disconnect and lower the massive General Electric turbofan engine. Only then, with the heavy engine removed, could they unbolt and detach the mounting pylon from the wing. It was a safe, proven procedure, but it was also incredibly labor-intensive. In the late 1970s, the American airline industry was entering the era of deregulation. Profit margins were shrinking, and an airliner only makes money when it is in the air. Time spent in the maintenance hangar was lost revenue. Looking for ways to improve operational efficiency, maintenance supervisors at American Airlines and Continental Airlines independently developed a shortcut. Instead of separating the engine from the pylon, they decided to remove the entire 10,000-pound assembly as a single, combined unit. To achieve this, they employed a massive industrial forklift. Mechanics would drive the forklift under the engine, support its immense weight, unbolt the pylon from the wing, and slowly lower the whole package. This unauthorized procedure saved approximately 200 hours of maintenance time per aircraft. In the spreadsheet logic of airline economics, it was a brilliant innovation. In the physical reality of aerospace engineering, it was a recipe for catastrophe. A forklift is a blunt, hydraulic industrial tool entirely unsuited for the microscopic tolerances of aircraft maintenance. As the mechanics unbolted the pylon, the forklift operator had to perfectly balance 10,000 pounds of metal. If the forklift hydraulic system bled down even a fraction of an inch, or if the operator misjudged the angle of the boom, the massive weight of the engine would suddenly pivot, acting as a giant lever against the pylon's aft bulkhead. The mechanics could not hear it, and they often could not see it, but the immense torque was snapping the upper flange of the pylon mount. Every time this forklift procedure was performed with less than absolute perfection, a microscopic fracture was introduced into the metal. Once the aircraft was returned to service, the normal aerodynamic stresses of takeoff and landing would cause that crack to silently grow. On May 25, 1979, as Flight 191 accelerated down the runway in Chicago, the crack in its left pylon finally reached the point of absolute structural failure. The engine ripped away, severing the hydraulic lines and dooming the aircraft. When the NTSB published its findings, the narrative suddenly shifted. McDonnell Douglas was formally absolved of direct responsibility for the crash of Flight 191. The primary cause was definitively ruled to be the unauthorized, reckless maintenance procedures utilized by the airlines. The FAA rescinded the grounding order, and after rigorous inspections and repairs, the DC-10 was legally cleared to fly again. But the NTSB report did not entirely exonerate the manufacturer. While the airlines had broken the pylon, the investigators noted that McDonnell Douglas had designed an incredibly unforgiving machine. The DC-10's pylon was technically strong enough to fly, but its design lacked the robust, fail-safe redundancies found in competing aircraft like the Boeing 747 or the Lockheed L-1011. Furthermore, investigators discovered that McDonnell Douglas engineers had actually become aware that airlines were using forklifts for engine removal. They knew it was dangerous, and they had issued a low-level advisory against it, but they had failed to forcefully intervene or demand the FAA stop the practice. Most damning of all was the vulnerability of the leading-edge slats. The NTSB noted that when the engine ripped away, it severed the hydraulic lines powering the slats on the left wing. Because the DC-10 lacked mechanical locking mechanisms to hold the slats in place if hydraulic pressure was lost, a feature present on other airliners, the aerodynamic pressure simply pushed them shut, causing the fatal stall. The crash was initiated by a maintenance error, but it was compounded into an unrecoverable disaster by a fragile design philosophy. In the end, the distinction between a maintenance error and a design flaw mattered greatly in the court of law, but it meant absolutely nothing in the court of public opinion. The American flying public did not read NTSB metallurgical reports. They only remembered the towering fireball at O'Hare and the terrifying month when the government declared the airplane unsafe. Despite its recertification, the psychological damage was permanent. In the minds of passengers, the McDonnell Douglas DC-10 was permanently tainted. It had survived the wide-body war, it had survived the Paris scandal, and it had survived the federal grounding, but it could not survive the loss of faith. The aircraft would continue to fly, but its era of prestige was over. It was no longer the flagship of the future. It was a lingering ghost of the 1970s, flying out its days under a heavy shadow of mistrust. Yet in a bitter irony that defined its entire existence, the machine that the public feared the most would soon be called upon to perform one of the greatest mechanical miracles in the history of flight. 10 years after the disaster at O'Hare and the subsequent grounding, the McDonnell Douglas DC-10 had largely faded from the headlines. The wide-body war was over. The aviation industry was moving toward a new era of highly efficient, twin-engine aircraft, and the massive trajets were slowly transitioning from the prestigious flagship routes into the grueling, everyday routine of domestic hub-and-spoke networks. The aircraft had proven its operational reliability over millions of flight hours, yet its reputation remained scarred. In the collective memory of the American public, the DC-10 was still viewed with a lingering, quiet apprehension. But on July 19, 1989, the DC-10 would be called upon to endure a mechanical nightmare so profound that it defied the very laws of aerodynamics. In doing so, it would completely rewrite the final chapter of its legacy in the passenger market. United Airlines Flight 232 was a heavily booked midsummer flight traveling from Stapleton International Airport in Denver to Chicago's O'Hare. The aircraft was a 15-year-old DC-1010 carrying 285 passengers and 11 crew members. In the cockpit was a highly experienced crew: Captain Al Haynes, First Officer Bill Records, and Flight Engineer Dudley Dvorak. Cruising peacefully at 37,000 feet over the sprawling farmlands of Iowa, the flight was completely unremarkable until exactly 3:16 p.m. Without warning, a massive explosion shook the rear of the aircraft. A terrifying, grinding vibration tore through the airframe, followed by the immediate shutdown of the number 2 engine. The power plant mounted high in the tail. The pilots immediately initiated the standard emergency checklist for a failed engine. But this was not a simple flameout. Deep inside the General Electric turbofan, a microscopic manufacturing defect in the titanium fan disc, a flaw that had existed since the engine was cast 16 years earlier, had finally succumbed to metal fatigue. The massive disc had shattered at supersonic speed. This is known in aviation as an uncontained engine failure. Instead of being captured by the engine cowling, razor-sharp fragments of heavy titanium exploded outward like shrapnel from a bomb, tearing through the tail section of the aircraft with devastating kinetic energy. In modern commercial aviation, redundancy is the ultimate safety net. The DC-10 was designed with 3 completely independent hydraulic systems. These systems provide the immense fluid pressure necessary to move the massive control surfaces: the elevators, the ailerons, and the rudder. If one system failed, the second would take over. If the second failed, the third would provide enough control to land safely. However, because the 3 engines were spread across the wings and the tail, the hydraulic lines had to converge in the rear of the aircraft to draw power from the tail engine. When the titanium fan disc exploded, the shrapnel sliced through the tail structure with such catastrophic precision that it severed the pressurized lines for hydraulic system 1, system 2, and system 3 simultaneously. In the cockpit, First Officer Records pulled back on his control yoke to correct a sudden dip in the nose. The yoke moved freely, offering absolutely no resistance. He turned it to the left to correct a right-hand bank. The aircraft did not respond. He pulled harder, pulling the column all the way to his chest. Nothing happened. "I can't control the airplane, Al," Record said, his voice remarkably calm but laced with absolute dread. Captain Haynes took his own controls. He experienced the exact same terrifying deadness. The hydraulic fluid, the lifeblood of the airplane, had completely drained into the Iowa sky. The control surfaces were frozen. The DC-10, a 300,000-pound machine loaded with human lives, was now an unsteerable, ballistic object drifting into a slow, descending right-hand spiral. According to every engineering manual, every aerodynamic theory, and every simulator protocol at McDonnell Douglas, a total loss of hydraulic pressure was an inherently unsurvivable event. There were no backup cables. There were no manual overrides. The crew of Flight 232 was trapped in a dying machine. As the crippled widebody continued its relentless, spiraling descent toward the ground, a miraculous stroke of fortune occurred. Sitting in the first-class cabin as a passenger was Dennis Fitch, an off-duty United Airlines DC-10 flight instructor. Hearing the explosion and recognizing the severe attitude of the aircraft, Fitch offered his assistance to the flight attendants and was immediately invited into the cockpit by Captain Haynes. When Fitch stepped onto the flight deck, he witnessed a scenario that had never been successfully navigated in the history of commercial aviation. The flight crew was wrestling with dead yokes while the aircraft was caught in a phugoid oscillation, a terrifying aerodynamic wave where the nose would drop, the aircraft would accelerate and gain lift. The nose would pitch violently upward, the aircraft would lose speed, and the nose would drop again. Captain Haynes assigned Fitch to the center console to control the only functioning mechanisms left on the airplane, the throttles for the two wing-mounted engines. What followed was one of the most astonishing displays of airmanship ever recorded. Fitch knelt between the pilots and took a throttle lever in each hand. To bring the right wing up, he pushed the left throttle forward, using the asymmetric thrust to physically twist the heavy aircraft. To stop the nose from pitching up, he pulled both throttles back. To raise the nose, he shoved both throttles forward. It was a crude, agonizingly slow method of control, fighting against the immense momentum of the widebody jet. It was the same principle Captain Bryce McCormick had used over Windsor 17 years earlier, but McCormick still had partial hydraulics. The crew of Flight 232 had nothing but engine thrust and raw intuition. Working together with absolute methodical professionalism, the four men in the cockpit managed to break the downward spiral. Communicating with air traffic control, they pointed the battered nose of the DC-10 toward the nearest available runway, Sioux City Gateway Airport. Steering the massive Tri-Jet with throttles was like trying to thread a needle with a sledgehammer. Every adjustment took seconds to take effect. As they approached the airport, the aircraft was coming in far too fast and descending at a terrifying rate. The crew could not deploy the wing flaps to slow down, nor could they properly brake on the runway. They were fundamentally executing a controlled crash. "Brace for impact," Captain Haynes broadcasted to the cabin. Seconds before touching down, the right wing suddenly dipped violently, a consequence of the erratic aerodynamics of the damaged tail. At 3:24 p.m., the right wingtip struck the concrete runway at 250 miles per hour, spilling highly flammable jet fuel. The right engine instantly tore off. The DC-10 slammed violently onto the runway, cartwheeling into the air, its tail section snapping off completely. The massive fuselage tumbled end over end down the concrete, erupting into a monstrous fireball before finally coming to rest upside down in a cornfield adjacent to the runway. The visual horror of the crash, captured on video by local news crews, was absolute. To anyone watching the catastrophic disintegration of the widebody jet, it appeared certain that all 296 people on board had perished. But as the smoke began to clear and the sirens of the Sioux City emergency responders wailed across the tarmac, a profound miracle emerged from the shattered aluminum. Passengers began to crawl out of the inverted fuselage and walk into the corn. The devastation was severe. 101 people lost their lives in the brutal impact and the ensuing fire. But astonishingly, 184 people survived, including Captain Haynes, First Officer Records, Flight Engineer Dvorak, and Dennis Fitch. The Sioux City crash profoundly shifted the narrative surrounding the McDonnell Douglas DC-10. Yes, the aircraft had suffered a catastrophic failure, But that failure was traced back to a microscopic flaw in a General Electric engine part, not a fundamental design error by Douglas. More importantly, the aftermath proved the immense structural fortitude of the DC-10's cabin. Despite tumbling end over end at 250 miles per hour and being engulfed in flames, the core fuselage had held together just enough to protect the majority of its passengers. The aircraft that had once been labeled a death trap had taken a completely unsurvivable, apocalyptic beating and refused to yield entirely. Coupled with the superhuman skill of the American flight crew and the rapid response of the Sioux City rescue teams, the resilience of the airframe provided a final, emotional redemption for the DC-10. It would never shed its troubled history, but on a hot July afternoon in Iowa, the compromised giant proved that it could also be a vessel of salvation. The passenger era of the Trajet was nearing its twilight, but it would exit the stage having authored one of the greatest survival stories the sky had ever seen. By the early 1990s, the McDonnell Douglas DC-10 had achieved a quiet, working-class redemption. It had survived its troubled birth, the catastrophic cargo door scandal, and the brutal grounding of 1979. Through millions of incident-free flight hours and the awe-inspiring resilience demonstrated in Sioux City, the massive wide-body had proven its fundamental strength. But the commercial aviation market is notoriously unsentimental. An aircraft does not survive on redemption. It survives on operating economics. And the economic foundations that had justified the existence of the Trajet were rapidly collapsing. The DC-10, like its rival, the Lockheed L-1011, was born to solve a specific mathematical problem of the 1960s. Engine technology at the time could not produce a power plant, reliable or thrust heavy enough to push a massive wide body safely across an ocean with only two engines. Therefore, aviation regulators enforced a strict rule. Twin-engine aircraft could not fly more than 60 minutes away from a diversion airport. To fly long, over-water routes or cross desolate terrain, an airliner needed at least 3 engines. The Trajet was the ultimate compromise between the excessive fuel burn of a 4-engine Boeing 747 and the regulatory limitations of a twin-engine jet. But technology did not stand still. Throughout the 1980s, jet engines became exponentially more powerful and remarkably reliable. The Federal Aviation Administration and global regulators recognized this shift and introduced ETOPS, Extended Range Twin-Engine Operations Performance Standards. ETOPS was a regulatory revolution. It certified modern twin-engine aircraft, like the Boeing 767, to fly long, oceanic routes previously reserved for planes with 3 or 4 engines. Suddenly, the entire logic of the Trajet was rendered obsolete. A third engine was no longer a safety requirement. It was simply a financial burden. It meant a third engine to buy, a third engine to fuel, and a third engine to rigorously maintain. When Boeing introduced the massive twin-engine 777 and Airbus launched the A330, the fate of the 3-engine airliner was permanently sealed. They could carry the same payload as a DC-10, fly just as far, and do it with a staggering reduction in fuel and maintenance costs. To survive this technological disruption, McDonnell Douglas needed to build an entirely new, twin-engine wide-body. But the corporation was trapped in a financial downward spiral. Devastating cost overruns in its military division, combined with shrinking margins in the commercial sector, meant the company simply did not have the billions of dollars required for a clean sheet design. In a desperate bid to stay relevant, they introduced the MD-11 in 1990. It was not a new airplane. It was essentially a stretched, digitized DC-10 with winglets and a modernized glass cockpit. But the MD-11 consistently failed to meet its promised fuel burn and range targets. Major airlines canceled their orders. The market had moved on. The end of the American wide-body war arrived not with a spectacular failure, but with a quiet, inevitable boardroom signature. In 1997, financially exhausted and commercially outflanked, McDonnell Douglas was officially acquired by its fiercest rival, Boeing. The titan that had built the legendary DC series, the company that had fundamentally shaped the golden age of American aviation, simply ceased to exist as an independent entity. The name on the factory gates in Long Beach was changed. The commercial production lines were slowly wound down. As the new millennium approached, the major American legacy carriers began to systematically purge the DC-10 from their passenger networks. American Airlines retired its last DC-10 in 2000. United Airlines followed in 2001. Northwest Orient, the final major U.S. operator, flew its last passenger DC-10 route in 2007. But the airframe was not done flying. While passengers had abandoned the Trije, the cargo industry eagerly embraced it. Freight companies like Federal Express realized that the DC-10 was a massive, incredibly cheap asset. Boxes do not read NTSB reports. Freight pallets do not remember the scandals of Paris or Chicago. Ironically, the massive lower deck volume that had initially compromised the cargo doors now made the DC-10 one of the most capable freight haulers in the world. Stripped of its passenger seats, its windows plugged with metal, the DC-10 found a lucrative second life flying in the dark, moving the e-commerce economy of the modern world. Others were heavily modified into 10-tanker aerial firefighters, dropping thousands of gallons of retardant on American wildfires, using the raw thrust of their 3 engines to pull out of steep, dangerous canyons. Yet as a passenger machine, the era was definitively over. The final orders were fulfilled. The production line in Long Beach went silent. The passenger cabins were gutted. The liveries were painted over. The Trijes were flown to the desert. The sky belonged to the twins. Today, if you walk through the arid expanse of the aircraft boneyards in Victorville or the Mojave Desert, you will still find the skeletal remains of the McDonnell Douglas DC-10. Stripped of their engines, their liveries faded by the relentless sun, they rest in quiet, orderly rows. They remain massive, imposing machines, still shaped like the bold future that American aviation once fiercely chased. The story of the DC-10 is not simply a chronicle of a flawed airplane. To dismiss it as such is to misunderstand the brutal, unforgiving forces of commercial aerospace. It was an aircraft born into a crucible of impossible corporate pressure, tasked with winning a high-stakes wide-body war that left absolutely no room for error or delay. The ultimate tragedy of the DC-10 was that the margin of safety was quietly traded for a margin of time. When the engineers at Long Beach and Convair were forced to compromise on the cargo door mechanism, and when the Federal Aviation Administration chose a polite gentleman's agreement over a strict regulatory mandate, they were not acting out of malice. They were acting under the blinding, suffocating influence of the spreadsheet and the market share. But the sky does not read spreadsheets, and the laws of aerodynamics do not negotiate. The DC-10 became a devastating, highly public lesson in what happens when the relentless pursuit of corporate dominance overrides the uncompromising duty of engineering. It shattered public trust, cost hundreds of innocent lives, and fundamentally rewrote the relationship between aerospace manufacturers and government regulators. Yet it also proved its inherent resilience, serving as a reliable workhorse for decades and facilitating a miracle of survival above the cornfields of Iowa. The McDonnell Douglas DC-10 stands as a complex monument to human ingenuity. It was a machine that reached for the absolute pinnacle of 1970s technology, but was ultimately compromised by the very economic system that demanded its creation. If you found value in this deep dive into aviation history and the invisible corporate forces that shape the machines we trust with our lives, please consider subscribing to the channel. Leave a comment below and let us know which fallen corporate empire, legendary machine, or industrial collapse should we investigate next. See you in the next video.